Hey, today we are going to cover the proof and logic behind binomial theorem. So, without any further ado, let's begin. You are all likely very familiar with the identity a plus b the whole square, which you studied back in school. But what if we club things together more systematically? What if we analyze the pattern of a plus b raised to the power 0, then power 1, and so on all the way up to a plus b the whole cube? If we identify this pattern and arrange it to a triangle, the so-called Pascal's triangle, how does it look? To construct Pascal triangle, we start with three ones at the top, and each middle term is simply the sum of two numbers directly above it. However, this is not a complete proof, it is merely a pattern recognition. So, we now explore the logic behind the scene. A plus b to all power n is the product of a plus b multiplied itself n times. For sake of clarity, we label each factors with subscript a1 plus b1 multiplied by a2 plus b2 multiplied till all the way up to an plus bn. When we expand this carefully, we notice the following. There is exactly one term with the form an1 times a2 times a3 all the way up to an, that is a power n, and there are exactly n terms where 1b replaces a, such as a1 times a2 times all the way up to an minus 1 times b1. If we take the factors into a bracket, example b1 is plus b2 plus b3 all the way up to bn and so on. Continuing the analysis, the term contains two b's correspond to all combination of choosing two b's from n. For example, b1 b2 and b2 b3 and b3 b4 and so on. The first term becomes a power n times n choose. Since there is only one way to choose 0 b's, the second term becomes a power n minus 1 times b times n choose 1. Since there are n ways to choose 1b from n factors, the third term becomes a power n minus 2 b square times n choose 2, since we are choosing 2 b's out of n factors. This pattern continues all the way up to last term b power n times n choose n, and that's in its entirety is the logic of binomial theorem. A plus b the whole power n is summation of n choose k times a power n minus k times b power k, or k from 0 to 1.